Okay, so for in this video, we're going to look at law of cosines. When we're talking about law of cosines, we are essentially taking a non-90 degree triangle, and we're going to split it down on whatever this top angle is. We're trying to get whatever side is over here using this angle, right? So we're using opposing angle and side. So let's call this B. We'll call this side B as well. So yeah, we're trying to get, with the Pythagorean theorem being used on triangle 1 and 2, because we split the largest whole triangle. So what we're going to do is we're going to take sine and cosine of angle B, and then we're going to apply that knowledge to this side and this side in order to get B in terms of that angle. So let's see this in practice. If I created this triangle, right, and like I said, we're going to try and find B in terms of angle B. To do that, we're going to need to define this height from that angle. And we're going to also have to find the base from that angle. We'll see why in a minute. What we're essentially going to do is we're going to subtract the purple part of the base from the total, and that will leave us this yellow portion on the right. So remember our Pythagorean theorem is base squared plus height squared equals hypotenuse squared. I didn't want to say a squared plus b squared equals c squared in this case, considering we're using those variables. So I just used words. And we're going to try to determine the lengths on the left side of the triangle. So again, we're going to try and find that purple base. So the cosine of b is going to be the purple portion over the hypotenuse, right? Adjacent over hypotenuse. Solve for a by itself, or the base by itself. So we solve for that purple portion by itself. Now we just need the red height. So we're going to do that as well. Sine of b equals the red height over hypotenuse. See if that's true. We see that it is. In that case, we can solve for height by itself. Now we have the red height and the purple base. In that sense then, as I stated earlier, the yellow portion of the base, so the right side, is going to be equal to the total length of the base minus the purple portion. And we've worked that out here. Base 2 is equal to c minus a cosine b. Now I want to put the side b in terms of angle b with the Pythagorean theorem. So we have our two sides, and we know that the hypotenuse is b squared. So we don't really need to go back up to that triangle anymore to observe it. We're going to take this this base 2 that we have. So c minus a cosine b all squared, right? A squared, and then we have b squared. Well, actually, as I said earlier, let's not use the general terminology a squared plus b squared equals c squared. We can use base squared times height squared equals hypotenuse squared. We got our base squared, and the height does not change regardless of which sub-triangle we're looking at of the whole. So we're going to do the a sine b squared for the height, and then, as I said earlier, we're going to look for b squared, because we have this now in terms of angle b. So we've got this c minus a cosine b squared. That's a binomial, so we're going to split it apart, right? That squared means that whole thing times itself, and then we're going to distribute everything through. Once we do so, we can combine like terms. I've underlined that portion in purple to demonstrate that that's happening in that step. And then we're going to perform the Pythagorean identity by pulling the a out of the two furthest right terms on the left side of the equation. Right? There's an a squared in both. Pull the a squared out, and then we have cosine squared plus sine squared, which equals 1. And we proved that when we created our unit circles in the first place. So we plug in a 1 there, and then all we have to do is rearrange. So b squared equals a squared plus c squared minus 2ac cosine b. And that is the law of cosines. Obviously, we could have done this from the other two angles as well, right? This isn't a 90-degree triangle, so we're not limited. So you could have two other variations of this thing as well. A squared equals b squared plus c squared minus 2bc cosine a, and c squared equals a squared plus b squared minus 2ab cosine c. And that gives you this one. This formula then is going to give you what the Pythagorean theorem did, but for any triangle in existence, not 90 degrees.